Hey guys, welcome back. It's Mr. Marone here. Today we're going to talk about deductive reasoning. So earlier in this chapter I talked about the fact that there's two different types of reasoning we'll look at. We've looked at inductive reasoning or reasoning from patterns. Now we're going to look at deductive reasoning. So the definition of deductive reasoning is the process of being able to reason using logic and drawing a conclusion from given facts and statements. So before with inductive reasoning we were using patterns that were given to us, where here we're just going to be using facts and statements. And from within that, there's going to be two different laws that we're going to look at. The first one is called the law of detachment. And that definition is that if I'm given a conditional statement, if the hypothesis is true, then the conclusion is true. So in order for us to be able to use the law of detachment, we've got a true conditional statement, and then if the hypothesis is true on its own, then the conclusion would also be true on its own. And we've got what's called a symbolic map. So if I were to draw this out for you, it would be if P, then Q, which we know, and then we would say that P is true. So this and this are both true. We would draw a line and we would put three dots in a little bit of a triangle shape, and we would say Q. And what that three set of dots means is therefore. So I'm just going to draw off on the side here. I've got my three dots, and that's going to equal therefore. Like I've said in the past, mathematicians are super lazy. So this says that if we have a true conditional, if P then Q, and if the hypothesis, if P on its own is true, then we can say that Q is also true. So let's take a look at a couple examples so that it makes a little bit more sense. So here's two examples. You guys have them in front of you, so we'll work through it. So if we use our normal process for conditionals, this says if Mark saves $30, which we said is normally P, then he can buy a new video game. That would be our conclusion, which we will circle, Q. So that's a true statement. If Mark saves $30, he can buy a new video game. Who's to say that he can't do that? Then they tell us that Mark saves $30. So he makes P true. So we can conclude then that Mark can buy a video game. Okay, so we said if P then Q, which we had, then we state P over again. We say that it's true. Therefore, we can say the conclusion is true. It's a little tricky, but let's take a look at the second one. Here it says if a quadrilateral is a rhombus, so that is our hypothesis, so that's P, then it is also a parallelogram, would be my conclusion, Q. And then they state that quadrilateral ABCD is a rhombus. So this right here is the same thing that we had already. This is P again. Okay? So our conclusion is that we can say that quadrilateral ABCD is also a parallelogram. Okay, so being able to identify these things through law of detachment makes our lives very easy when we use deductive reasoning. Here we were just given facts and just given statements, and we're able to conclude information based off of that. Now, if there was a case where there wasn't a conclusion, we couldn't draw anything from it, you would just state no valid conclusion. At this point, I want to invite you to pause the video and try problems 3, 4, and 5 on your paper. See if you can come up with stuff, and we'll talk about them tomorrow in class. So the second type, a second law we're going to look at today is called the law of syllogism. It's kind of a silly name, but that's what we've got here. And the law of syllogism states that we can draw a conclusion from two conditional statements. And there's a really big key here. The conclusion of the first statement has to be the hypothesis of the second statement. So if we used our symbolic map again, we could say if P, then Q. And once again, our conclusion of the first one has to be our hypothesis of the second one. So if Q, then R. We'll use just a second letter. Okay? And what we can do there is draw a conclusion that therefore, if P, then R. Okay, so if P then Q, if Q then R, therefore if P then R. So it's a little bit of a connection there, and it takes a little bit to look at. It takes a couple examples to really see what this looks like. Let's take a look at examples 6 and 7 on your paper. So in the first statement, it says if it is Saturday, this is P, then Jake has a basketball tournament. Okay, and we'll say that's Q. Now this next conditional statement, it says Jake has a basketball tournament. That is the same statement here. So we're going to say that's Q, and then I'm going to circle this over here and say that's R. So since it says if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. We can say that if it is Saturday, then Jake will need to pack his lunch. Okay, so we were able to say if P, if it is Saturday, then R, Jake will need to pack his lunch. We take a look at the second one here. It says if a number is divisible by 12, that would be our P, then it is divisible by 6. That's our Q. Now, Q is stated again here. If a number is divisible by 6, that's Q, then it is divisible by 3, which is R. So once again, we have the conclusion of our first one is the hypothesis of our second one, so the law of syllogism holds here. So we can say that if a number is divisible by 12, if a number is divisible by 12, then it is divisible by 3. So what I'd like you to do now, I'm going to finish up my video here. You've got 4 more examples for you to try before we come into class tomorrow. Okay? Just like with the law of detachment, with the law of syllogism, if there's not a valid conclusion, if we have if P then Q and then if R then Z, we don't have a valid conclusion. You would simply write no valid conclusion. So keep an eye on that. They're not always going to be true. Hope this was informative. Make sure to ask any questions you have on the video tomorrow when you get into class, and have a great night.